Okay, this is Algebra 1, Part 1, Lesson 4.3, Patterns and Nonlinear Functions, page 248, Problem 2, representing patterns and nonlinear functions. And basically what that means is putting them into a chart, table, graph, even if it's not a line. So over here, for example, what they're doing is if it's one wide, if you have one blocks on the edge, how many total number of blocks are there? Well, there's only one because you've only got one right there. If you've got two across and two up, so we're making these square. This is a 1 by 1, which is only one block. This is a 2 by 2, which is actually 4 blocks. Sorry, I lied. 2 by 2 by 2, it's a volume. 2 this way, 2 this way, and 2 that way. There's actually, if you count them, there's actually 8 blocks there. So we're talking about volume. If it was 3 tall, 3 wide, and 3 long, 3 times 3 times 3 is 27. Okay, so basically what's happening is we're cubing this number. 1 to the third power is 1, 2 to the third power is 8, 3 to the third power is 27, which is going to make the next one 4 to the third power is 64, 5 to the third power is 125. And then over here it's showing it as an actual point where the number of edges you have is your x value, the total number of blocks that gives you is your y value. So we're putting that into points, and then you put that into the calculator using your stat function. Make sure that your plot is turned on. And it says right here y equals x cubed. That's what I said it was. The points do not come out on a straight line. That's more of a curve, which means it's a non-linear function. Okay, so for problem 2, I'm going to go over here on the right. For problem 2, it says the number of new branches in each figure of the pattern. So one tree has 3 branches. 2 trees has 3 on each of those 3 branches. So 3 times 3 is 9. Number 3 has the original 3 branches, 3 on each of those, and then 3 on each of those. So this is basically 3 to the first power is 3, 3 to the second power is 9, 3 to the third power. So we're basically doing 3 to the nth power, where n is your x value basically. So 3 to the x power. And just by that form of the equation, we already know it's not going to be linear, it's going to be exponential because it's the exponent that's changing. So we're multiplying each branch by 3, which means we're doing y equals 3 to the x power. So if you put it in your graphing calculator, it would look like this. Again, you're using your stat function. Go to stat edit, and you're going to put in your x list in list 1 and your y list in list 2. Make sure your plot is on, and then graph it and do a zoom stat, and it will show you this. Okay, so no, that's not linear. It's going to be nonlinear. But because we now know the pattern, we're just taking 3 to this power up here. 3 to the third was 27, so 3 to the fourth is 81, and 3 to the fifth is 243 if you put those in your calculator. I guess that's all it wanted. Let's see, what is a pattern you can use? Okay, so we came up with the pattern. Represent the relationship using words, an equation, and a graph. So the words, we're multiplying each branch by 3, then each of those by 3, etc. That's what's going to keep happening. Here's the equation. Here's your missing values. Here's it represented as a graph.